at the beginning of these, I want to add something to the notes from the previous notes. So this first part goes to the last notes that we took, not on today's notes. I just want to talk real quick about isosceles triangles. I talked about it in class, but there's a theorem or a postulate or something that says that if you have isosceles triangles, the base angles, which are the angles at the bottom opposite of each one of those sides, the base angles are also going to be congruent. So it doesn't matter how it's shifted. If it's an isosceles triangle, you'll know that the base angles are congruent. Another way to look at it is if you have the base angles that are congruent, then you know the opposite sides are going to be an isosceles triangle, or they're going to be congruent as well. All right, so that's the first part of today's notes, but I want to go ahead and jump straight into today, which is really talking about triangle congruence. All right, triangle congruence is the idea for today. Now, we talked about this in class, and so I'm not going to go a whole bunch into this. I just want you to get this stuff written down. The main idea is that congruent objects have the same shape and the same size. No matter how they're rotated, they have the same shape and same size. And so if two things are congruent, all the parts that correspond are also congruent. And so what that means is the parts of the figure that are congruent, like the side to another side is congruent, and an angle to another angle. And so that's the important part. Once we determine that two things are congruent, then all the corresponding parts match. Now here are 4 of the ways that we will prove that triangles are congruent. And the idea is that you have to show that one of these exists in order for you to say that triangles are congruent. Let me say that again. You have to prove that one of these exists before you can say that triangles are congruent. And so what's really important is that you understand this word right here, included, 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 included. Angle, side, angle, the angle has to be sandwiched in between the two sides. Angle, side, angle, the side has to be sandwiched in between the two angles. Now notice that angle, angle, side is non-included. And basically the idea is if I can prove that 3 sides are congruent, then I can say the 2 triangles are congruent. If I can prove that a side, included angle, and a side are congruent in 2 triangles, then I can say they're congruent. Same thing goes for each one of these. And so that's the idea. This is the only one that the order doesn't matter. Angle, angle, side says 2 angles and a side that you have in the problem. And what I'd like to do with this is actually take time real quick to go over several examples. I want to try to make this clear by looking at the examples that we have here. So follow me. If I go too fast, pause and rewind. If you have any questions, let me know in class. All right? So it says copy the figure. All right, we already got it down. Label the vertices of your triangle so that this triangle is congruent to that triangle, and identify all pairs of congruent corresponding angles and corresponding sides. Okay, so the idea is whenever you see a statement like this, this is called a congruent statement. And so what this says is that this vertex C corresponds with B, I, and P, and N and Y. And so whenever I make this triangle name, if I call this C, P, N, then I also have to do B, I, Y for those 3. It has to go in the same pattern. And so if I'm going to list stuff that are congruent, side or segment CP is congruent to segment what? BI. That's right. What about segment PN is congruent to segment what? IY. Segment CN is congruent to segment BY. You see that? I matched all the sides that correspond. This side corresponds to this side to this side, and so on. Now, what about angles? Okay, let's look at the angles. Angle P is congruent to angle, which one? I. Angle C is congruent to angle B. And angle Y is congruent to angle Y. You see that? Oh, I guess you couldn't. All right, let's keep moving because I got a lot of these I want to do. In the diagram, triangle EFG is congruent to triangle OPQ. Complete the statement. So they want me to fill in the blanks. They already told me that these two triangles are congruent. EF is congruent to OP. That's the side that it's congruent to. Angle P is congruent to angle F. You see that? Angle P and angle F. Angle G is congruent to angle Q. The measure of angle O. If these two are congruent, the measure of angle O has to be 110 degrees, just like this measure of angle E. QO equals 7 kilometers, just like this side over here. And triangle GFE is congruent to, and see how they wrote it, GFE, so I got to write it in the same way. It's congruent to triangle QPO. You see how I wrote it in the same fashion as how they wrote this one right here? They said GFE, and so I said QPO. If they said GEF, I would have had to say QOP. So I hope you understand that the order is really important when you're writing a congruency statement. Hopefully you got all that. I'm moving on. Write a congruence statement for any figures that can be proved congruent. Explain your reasoning. Now, you need to remember this stuff right here. You need to keep in mind all these ideas right here, okay? We need to know these. We need to have them in the back of our mind because I'm going to do some of this and see if I can keep that up. I don't know if I can. Nope, can't. Keep this up and try to, well, you got it written down, so I'll just let you have it. Now notice these two triangles, everything is congruent to everything, it seems like. And so with these two triangles, I can prove that triangle GEI is congruent to triangle M in the same order, QO. And I can tell you why. Well, what about side, side, side? You see how these sides match up to each other? So I can use side, side, side here because it works. I can use angle, side, angle. That's one of them. I can use side, angle, side. You see how these match up in each one of them? This one, everything is congruent. And I can do angle, angle, side. Angle, angle, side. This one, since everything is congruent, you could say that these triangles are congruent because any one of those will work. Let's look at number 9. Number 9, you have a side, an angle, and a side. Or if you go this way, side, angle, and a side. Do I have that same order in this one? 1 mark, angle, 2 marks. So side, angle, side. Is that one that I could use? Yes. So what you do is you say triangle, not A, you say triangle TRV, that's the way I just chose to go, is congruent to triangle YXZ, and then you would say by side, angle, side. Now let's look at number 10. Number 10, I have side and a side. See those two match? I got another side, and I have 2 angles. Nope, actually I don't have 2 angles. You see how this one matches this one? And, oh yes I do, and this one matches this one. But notice how they share this side. Whenever 2 figures share a side, you know that side is congruent. So I could say, if I wanted to, triangle KLN is congruent to triangle MNL, and I can say by side, 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 because all 3 sides match. Okay, they share a side, so I can actually put the 3 marks right there for both of them. I can also say angle, side, angle. Well, angle, side, angle here on the bottom. Angle, side, angle. There's several of them on these. This is just kind of giving you the idea of how you can figure it out. But I want to keep going because I want to show some that you don't have all of them that you can pick from. All right, this one asks us to solve for the value of angle y. Okay, and if we assume, I don't think we have to assume, but we have a right triangle. If this angle and this angle match, and this angle and this angle match, then angle y has got to be the same, because we already know this one is 90 and those two match, so that means this one has to be 65. And so in order for us to find that, we can either do 65 plus 90 minus 180, or we'll just say 65 minus 90, and so y would be 25, because 25 plus 65 is 90, which those two would be. And how do I know that? Because of the figure here. I know that those match angles of right angles. Those two angles match, and so this one would have to match that as well. Or at least I know that for this triangle. Skipping down here, find the value of angle y. Well, this one I'll try to work out in class, just because I want to get to some of the other questions. There's some of just really important that I want to get to, and I'm running out of time. So let me start here. This says, state the third congruence that is needed to prove that these two triangles right here are congruent. All right. So if I know, and I want to use angle, angle, side, that means I need two angles and I need a side. Okay. And so if they tell me that DE is congruent to AB, so I know this and this is true, and they tell me angle A and angle D, what else do I need to know in order to prove angle, angle, side? Well, I would need to know that I need another angle. See, I got a side and I got angle, so I would say maybe angle E is congruent to angle B. That would be actually that would be side angle side, wouldn't it? Angle side angle. So that wouldn't be correct. That's incorrect. I shouldn't use that one. That is incorrect. If I'm trying to do angle angle side, I would do angle F and angle C. Angle F and angle C. Because angle angle side, you don't have to have an order. You don't have to have the side sandwiched in between. Let's try another one. If they want us to use angle side angle, I kind of just gave that away. If they tell us that FE is congruent to CB, if we start it all over again, FE congruent to BC. If FE is congruent to BC and F is congruent to angle C, and they want us to figure out using angle side angle, so I need another angle, angle side angle. This one would be angle E and angle B. What about side angle side? If they gave us the information that they give us to show side angle side on number 6, side angle side says DF is congruent to DF is congruent to AC, and angle F is congruent to angle C. I am tripping, trying to go fast. Angle F is congruent to angle C. So if we need to do side angle side, side angle side, so it'd be BC. I would need BC to be congruent to EF. Now I hope I just didn't completely mess that up. If you got questions on that, I'll try to figure that out. I'll try to clear it up for you. Let's just do one of these. Let's do the angle angle side again. If angle C is congruent to angle Z, all right, and segment AC is congruent to XZ, so we got AC and XZ, all right, use the angle angle side congruence theorem. So if it's angle angle side, it can't be angle A and angle X, because they don't need to be sandwiched in between the side. That'll be angle side angle. But angle angle side says use any other angle as long as it's not between there. And so this would be angle B is congruent to angle Y. Now I'm going to probably make another video because I want to do more examples. So I'll stop right here and I'm going to do some up.